Right, thanks Kai, and good morning everyone. So yes, my name is Carsten Ziegeler and I'm Principal Scientist at Adobe, member of the Apache Software Foundation and also involved in all the OSGi specifications. But this talk is obviously not about me, but about connecting the best stuff that you will find in Java world together, which is OSGi of course and Spring. I mean, some people might say it's the worst stuff that you combine, but in my opinion, it's the best stuff. For that, I would be interested here in the audience, who of you is using OSGi? Okay, that's nearly everyone. And Spring? Okay, good. That's good. So that matches somehow. And the interesting thing is that more people here are using OSGi than Spring, so that tells you something. But maybe it's because it's the OSGi track that might influence it a little bit as well. Okay, before getting to how to connect these things, a little bit about modularity, because I think that's because in my case, it's a little bit the driving factor why I did this work and tried that out. If you think about developing software today, we are really developing very complex, large systems, especially systems in the cloud, which are divided up into a lot of microservices that somehow connect to each other, and all these different things. Even desktop applications are still growing and getting bigger and bigger. We saw this talk on Tuesday in the keynote with all these modeling stuff and so on. So software is getting more and more complex, and the question is, how can you manage this complexity? And obviously the answer to that is modularity. Just one interesting fact is, I grew up in the 80s, that dates me a little bit at least, and early in the 80s I read an article from Brad Cox, who is the inventor of Objective-C, which you might know from all the Apple stuff, and he coined the term software ICs. If you think way back, 60s or 70s I guess, ICs, so integrated circuits, revolutionized the hardware industry, right? Before that it was bolting down these little things together to get a computer running, and then later on someone came up with the idea of ICs, and these ICs are basically like modules. They specify the requirements that this thing has, because it's specified how much voltage you need to connect on whatever pins, but it also specifies what this thing does very, very well. So basically that's kind of module in the hardware world, and Brad Cox and a colleague of him translated that to the software industry. And when it comes to modules, it's really important that you define your requirements and capabilities of your module, and you can use modules to build your larger system. Now, as I said, modularity is really key to build complex software out of smaller pieces, these modules. It helps you in maintaining your software and in really creating sustainable software that hopefully lasts for the next decade or something. And if you want to build something that only lasts for some months, maybe use something different. The other thing is modularity allows you to do extensibility, right? It gives you the base building blocks to define a plugin concept, and obviously Eclipse is a good example of doing that. But it also, and then that's basically the point for my talk, is it gives you interchangeability, so you can swap out modules as long as they satisfy the same requirements. But it also allows you to do reuse and have consistency. So for example, if you think about the cloud, you're developing your 25, 30, whatever microservices, then you might want to have at least some consistency across these services, as you want to reuse the same basic building blocks like logging, monitoring, configuration. You don't want to do it differently in every microservice implementation. And that's where this comes in very handy. Now, obviously, when you think about modularity in Java, there is the solution to it, that's OSGi. And as nearly everyone here knows OSGi, I guess that's a known fact as well. With OSGi, you can define your modules, you define your requirements, capabilities. Usually this is what the package imports that you need to run your bundle, and the packages that it exports for others to use. But again, in OSGi, we have this more general concept of requirements and capabilities, so you can define whatever you want in these requirements and capabilities. You can define that you need a database or whatever. And the other important part, it comes with versioning, right? So it uses semantic versioning, so you can specify my module needs that package in that version range, and then hopefully another module provides it with a version that matches that range. The other thing is OSGi has a service registry, so you can register services there, and then other modules can pick it up from there and use these services. So that's very useful as well. And if you want to develop services, there's, for example, the declarative services that you can use to implement these things. And Dirk had a talk yesterday about that one, right? Yeah. So if you're interested in that. So that's the basic building blocks you get with the base of OSGi. So that's one part of my world for this talk. The other one is Spring. Spring is obviously today, I think still today, the most popular IOC inversion of control container that you can use to develop your applications. It has a lot of extensions, right? There's Spring Security and Spring Reactive and all these different things. It comes with a lot of tooling, documentation, and so on. Very, very nice. And if you want to build microservices, there's Springboot, which helps you starting up very, very quickly to get something running. This looks all very, very good. Now, if you want to compare the two things, Spring and OSGi, I mean, it's like comparing two totally different things in the end. But if you focus on some of the core concepts, then you can still compare it. So with OSGi, we have the nice module concept with bundles, which also manages all the class loading between the bundles, right? Whereas on Spring, you just have a flat class path where all the jars are in this class path. And I mean, the term class path hell was like coined 15, 20 years ago, right? Where you have all these different jars on a single class path, and it might happen that you have the same, let's say, library in two different versions on the class path, and depending on how this flat list is organized, you have one version of it first or the other one, which can later on result in problems. And OSGi with a class loading solves that problem very well. Spring is more static. So once you have started up your application and the container with all the services started, it's more or less static. You can make it dynamic, but that requires a little bit of coding. Whereas OSGi is fully dynamic, right? You can add modules at runtime, you can add services at runtime, remove them, and that works pretty well. Obviously, it's maybe not that interesting adding modules at runtime dynamically, but adding services dynamically at runtime is very interesting, as services can, for example, model the real world, and in the real world, things come and go. And so if something happens, you can register a new service that, I don't know, your database is there, and if the database is gone, you unregister that service. So it can really model the world that you're building your software on. When it comes to containers, OSGi has this service registry where you can register a service and someone else can pick it up from there. And that's basically all of the functionality it gives you. Whereas in Spring, you have a full IOC container, which also instantiates your services, provides you with configuration and all these, and wires up the services together. And then that's not done automatically in OSGi, but if you're using declarative services, then you get that for free. So that's basically the IOC container layer on top of the OSGi framework. Again, the services are static and dynamic, as I said already. In Spring, if you register services or beans, it's called there. They are basically names that you come up yourself with, whatever names you want to use. So sometimes it's very hard to figure out from the name what that bean actually does. If you're very creative in naming things, then it can be very, very tricky. On the other hand, in OSGi, you use the interface name of that service to register that thing, so you can directly see what this service does. All right, so that's these two worlds, and depending on how you want to develop your software, you might think, okay, it's very nice that I have a class loader-based module system, which allows me to have dynamic services, but on the end, the IOC container of Spring is very nice. So you would like to match these things. In our case, it's a little bit more complex. So we are a heavy user of Apache Sling, which is a web framework. And when we want to build microservices, we want to use Sling, which is fully OSGi based. But on the other hand, we have a lot of teams using Springboot as well. And they already developed a lot of very useful libraries and services for authentication, monitoring, and so on, or connecting to our internal services. And we want to reuse that stuff. So the tricky thing is now really how to combine these things. I mean, you could try the naive way, maybe it's not naive, the obvious way, and try to run the Spring stuff in OSGi. That kind of works or might work, but then you have to figure out, because these Spring libraries use a configuration way of Spring. On the other hand, you have OSGi configuration admin to configure things. How do you match all that stuff? That might be tricky. You could try the other way around and use the OSGi stuff, Sling in this case, and run it on a flat class path with Spring directly, but then Sling on the other hand is too tightly coupled. It's using a lot of OSGi features, so that's not really possible either. So it's really better to try to combine these things. So we came up with basically this architecture. That's where you can see how we combine it. So on one hand, we start the application with Springboot, and then Springboot has already a web container in it. You can choose between different. In this case, we chose Jetty. We run all our libraries and then beans that were already using Spring in that area, in that domain. And then inside, we launch an OSGi framework where we use the HTTP service that connects to that Jetty that is already running. And we have Sling running and our application on top of it. And then we wanted to use these beans from Spring in Sling, and in the application code, and then maybe vice versa. To bootstrap all of that, we use something we call the feature model. And for those of you who were in the previous talk by David and Carl, you could learn a little bit about the feature model. That's basically, let's say, a textual description of all the bundles, the jars, the configuration of your whole application. And basically, we use that to bootstrap Spring Boot, the OSGi framework, and configure all these things. And then to really connect that stuff, there is the star on the horizon, which is OSGi Connect. And I get a little bit more into detail about that now. So how does this all work? There was already some work years ago which was called OSGi Connect, and we now this year rebooted that effort and basically come up with a specification that allows you to connect OSGi to the outside. There are different use cases for it. One of them is obviously the one I'm presenting here, but the basic thing, or the basic feature of OSGi Connect is that you can treat jars or stuff that you find on the normal class path, so outside the OSGi framework, as bundles inside your framework. And you can do some tricky stuff with that. And this basically allows to launch the OSGi framework inside Spring Boot and then treat the jars, like the different libraries we have in Spring, as bundles in OSGi, so you can use that API and basically build up your application out of that. And then the other thing, obviously, which is, I mean, so this solves the class loading issues and getting access to API and libraries and all of these things. But you also want to use the beans from Spring in OSGi and the OSGi services in Spring. And for this, you need to do some extra magic and map these things, just as the rough idea. And with that, I'm coming to a great demo. I used all my time to spend on this graphics. Yeah, you can see that, right? So it's more interesting than the demo, I guess. No, sorry. Okay, so. Oh, okay. Don't see anything. Or maybe this was your demo. It's a very nice demo, I guess. Okay, nothing to see. I have no idea what I did wrong, to be honest.
Just blame it on Windows.
Yeah, I blame it on Windows. I try the usual, I hope that's okay.
Yeah, right.
Yeah, it looks better. It's the usual Windows trick, right? You just reboot or reconnect or whatever. Always works. Sorry for that. So here I've running a running system, which is Spring Boot, as you can see here from the console, and as you can tell by the exception here, there's some OSGi running as well. So it's always a good indication. Now, more seriously. So in my application, I have a simple Spring Bean that's using the normal annotations from Spring. It's mounting that thing at /hello, and that works. As you can see over here, it's a little bit small, but it says hello over there. Nothing very exciting. On the other hand, I have an OSGi framework with Sling and the web console running in here, and you can see it here as well. And you can look, for example, at the OSGi configurations. The details do not really matter. It's probably too hard to read anyway. But you can see two check marks on two of these configurations. So this instance actually has two configurations stored in configuration admin. Now I've written a different endpoint, which also runs in Spring. And this one, again, it's not really important what it actually says there, but as you can tell by the number of lines, it prints out two OSGi configurations, or the names of the OSGi configurations. So this is really a servlet running in Spring using an OSGi service, the OSGi configuration admin in this case. So if we look at the code, yeah, this is the Hello World servlet, not very fancy. And actually this one, which is at the config endpoint, is not more fancy as well. It simply uses the configuration admin service and then the normal Spring mechanisms to reply to a GET request. So it really looks like a normal Spring application, but it's using the configuration admin as a service which is coming from the OSGi framework running inside Spring. As I said, this is all tied together by the feature model. So just to show you this is the list of bundles. Again, not important which bundles we have been running. You see here on top the different configurations we have in OSGi. And the interesting part are those two configurations down here. So this one, so basically what you need is you somehow need to map the services running in OSGi to beans in Spring and vice versa, right? What doesn't work is having some automatism there, because it's pretty hard from Spring to figure out what interfaces those beans implement, what they actually do. So just taking all the beans from Spring and registering in the service registry does not really work. The other way around is complicated as well, as Spring is using just names. And for example, in OSGi, you might have different services implementing the same interface. So you would need to have some automatism to generate the bean names. But then if you generate bean names, then later on the application developer does not know the name of that bean. I mean, it might be solvable in some way, but I thought it's maybe easier to simply, just a second, to simply configure this mapping. Okay, and in this case, so that's the upper part here. I'm configuring that the OSGi configuration admin, so that's the first part, has actually the bean name of the OSGi configuration admin. So the second thing here is the bean name. Yeah, that's a question.
Yeah, I'm just wondering if you could do that with using annotations on the classes.
Sure, yes, you could use annotations or any other mean. The problematic part with annotations is obviously that you need to have these annotations in the code already, right? So if you're, for example, using an already existing Spring jar which runs in Spring, it probably does not have any additional annotations, right? But yes, that's another approach to that. Yes, right. Yeah, so I just started with the most simple way and came up with the configuration. And the second one is actually the other way around, right? So you basically define which Spring bean is registered as an OSGi service in OSGi. So the first, my Spring bean is obviously the bean name, and the other one is the interface, which is used in the service registry to register Sling. And then you can mix and match all these beans and Spring and services in your code and use whatever you need. Okay, I think that's for my demo. No, I have to switch back. But I guess this time it will work better. So again, this is at the moment really a very, very rough demo or prototype, if you want, which allows you to connect these two worlds and use services from OSGi in Spring and beans from Spring in OSGi. What? You really want to make a photo? I could pose next to it. Okay. So basically, I think modularity is really key in general when it comes to building software. As I said, it allows you to build sustainable and maintainable software in the end. And in our case, it's really that we wanted to reuse already existing stuff in all our implementations and also have consistency across implementations, right? If there's already an authentication library that does this thing, then you want to reuse that in every microservice you build. And you don't want that a different team comes up with a different implementation and does the same thing, just slightly different, obviously. The other thing is that if you want to do modularity in Java, it's generally a good idea to at least add the OSGi metadata to your jars. whether you're using OSGi or not is maybe less important, because if you use the metadata on all your jars, you can already detect at build time if all your jars make up a running system. Right? You can check against the metadata, and you don't have to do that at runtime, probably. And with OSGi Connect, you really have new possibilities of assembling your applications. You can pick and choose the best pieces in the world that exist in Java land and connect them together to build up your application. Especially important as you can choose between which parts of your application you want to have dynamic, and which parts you don't need dynamics and just can go with static stuff. Right. So in our case, although it's a Springboot application, we have the OSGi framework running inside with Apache Sling. And we have all the dynamics of OSGi in there, right? So you can register bundles at runtime, you can add new services and all these things. And you could even bridge that again back to Spring if you want to. It's a little bit complicated, but it's possible. So if a new service pops up in the OSGi framework, you could register that as a bean in Spring. But probably or usually the code in Spring is not prepared for these dynamics. And with that, I think I'm at the end of my talk, except for the only link I have in my presentation. So as I said, we have this new specification which we are working on, the OSGi Connect stuff, which is the basic building block for all of this work. And you can watch at that Git location what we are doing there, as this is the RFC 243, and we are working next time on that one, and you can see whatever we are doing there, and obviously even better provide feedback and help out getting this stuff done. I guess I'm pretty fast. Oh no, that's good. So are there any questions? Yes.
Yeah. So how are you dealing with building the application? So even build, like how do you collect all the OSGi bundles together and put them in somewhere where you can get the framework and start them? How do you deal with putting them on class path so you can file out all that kind of stuff?
Yes, right, okay. Yeah, so for building the application, we are using this feature model. So that's this text file I've briefly shown, and basically in the end this feature file lists all the OSGi bundles. It also includes the configuration, and then there is some special Spring application code, right, which bootstraps your application, and that one picks that feature file and adds all the bundles to the class path, and then starts the framework and does all that stuff. So the feature model is somehow similar to Kara features. Yes, it's just a different format, a little bit more flexible. Let's put it that way. Yeah. Yes. Yes, correct. Yes, correct. Yeah. Yes, right. Yes. I mean, right. So for this prototype, I crafted that feature file by hand because I knew more or less which bundles I wanted to use. And then we have Maven tooling using that feature file and then bringing everything together. And then later on, that's then used in the application. But obviously, I mean, it doesn't define how you get to your feature file in the first place, right? So you can use different ways of doing that.
And does OSGi Connect, does that work with just like a standard Java application? So not using Spring at all. Say I just got a Java application and I want to use part of it just using the normal
Yes, it's yeah, right. So OSGi Connect is not, it's obviously tied to OSGi. You should from the name, but it's not tied to Spring or anything else. So you could really have a normal Java application, or yeah, it should be Java obviously, but it could use any framework or whatever, and then somehow connect to OSGi. But for that, and I had to do that for Spring as well. I mean, you need something that really connects these things, right? So that, for example, finds the Spring jars and registers these as bundles in OSGi, or maps the beans to OSGi services, or the other way around. And again, if it's a normal Java application, you have to think about how do you want to bridge these things. But yeah, it's definitely possible. Yes. Yes.
It'd be nice if the Java application just got wrapped into a bundle automatically. So essentially, from the OSGi side of things, it looks like OSGi. And so you can leverage services and whatever. And then the Java side could call the service registry and just get access to it. So it just thinks it's a Java application. And just accesses interfaces the same way that you do Java.
Yes. I mean, yeah.
I mean, you can do it. You could write the code that wraps it in a bundle to do that. But
Right.
the frameworks then, like getting that bundle into the framework is different for every bundle. So Felix lets you wrap in code a bundle, like just like a Java application, you can wrap it in a bundle, and you can give it to the framework programmatically,
Right.
and it will just start it like a system bundle. But in Equinox, you can't do that. I haven't found a way to do that.
Right.
So you actually have to separate out the Java code into a separate jar file and make it into a bundle, and then Equinox.
But actually, so this specification OSGi Connect is solving that problem. It standardizes how to do that. But still, I mean, an automatism to basically take everything that you have in your class path and then bringing that automatically as a bundle into OSGi is maybe a little bit difficult, because you don't know automatically what part of that stuff you want to export to other bundles in OSGi, right? For example, as a simplest case. So I think it's definitely doable to do something automatic, but I guess you still want to have some control over how the pieces really end up in OSGi. Yeah. Right. Yeah. Yeah.
If I understand, you use the feature file twice, once at fill time and then at the path.
Yes, correct. Yes, correct. Yeah. Okay. Any other question?
Just what's the plans for OSGi Connect? You're developing at the moment.
Right.
Do you have any plans for a release?
No, I think we don't have a release date for that. I mean, usually at least in the past, I think our specification, I mean, the specification work we do at the OSGi Alliance is not just this specification, it's a set of specifications we work in parallel. And then we usually do this big release, like the release 7 we did last year or maybe the year before. And the next one is obviously release 8. And it usually takes some time until all these things are done. So I think at the moment we have no idea when that will be. Hopefully sooner than later, because I mean this at least for us that's cool stuff we want to use. So that's the best thing, is really watching that Git repository, or even better obviously would be being part of the Alliance and helping moving things faster. Yes, but the thing that's currently in Felix is different than what the specification is. But Carl is working on implementing what is already there, or has already done it. Yeah. All right, I think we are at the end of the session, so thank you very much.